Quarter 4, test number 1 review, sections 7.3 to 7.5 solutions. All right, so for our first section, for 7.3, we are working with exponential and logarithmic equations. So for number 1, we have 4 to the power of 2x is equal to 6. So we first want to ask ourselves, can we turn this 4 into something to the power of that this 6 can also be turned into that same base to the power of? The answer is no, so we're going to take the log of both sides. So we're going to start by doing log 4 to the power of 2x is equal to log 6. So this 2x has to go out front, so we're going to have 2x times log 4 is equal to log 6. From here, we're going to divide each side by that log 4. So we're going to have 2x is equal to log 6 divided by log 4. From here, we are going to divide each side by 2. So we're going to put this in parentheses, and in our calculator, we are going to do log 6 divided by log 4. We're going to hit our enter button, and then from there, we're going to divide that by 2. And we get that x is equal to 0.65. For 2, we're given 8 to the power of 2x minus 5 is equal to 48. We can't turn that 48 into 2 to the power, something like we can with that 8. So we're going to take the log of both sides. So we're going to have log 8 of 2x minus 5 is equal to log 48. That 2x minus 5 is going to go out front, so we're going to have 2x minus 5 times log 8 is equal to log 48. From here, we're going to divide each side by that log 8. If you wanted to, for right now, you can do this in your calculator. So log 48 divided by log 8 gives us 1.861. So we're going to have 2x minus 5 is equal to 1.86, so on. From this, we are going to add the 5 to it. And then we are going to divide each side by 2. Oops. So in our calculator, from that log 48 divided by log 8, we hit that enter. We are going to add 5 to that and then divide that by 2. So we should get that x is equal to 3.43. For number 3, we have 4 to the power of x plus 2 is equal to 20. So this is going to become log 4 to the power of x plus 2 is equal to log 20. That x plus 2 goes out front, so it's x plus 2 times log 4 is equal to log 20. We are going to divide each side by that log 4, and then we subtract 2 from each side. So x plus 2 is equal to log 20 divided by log 4. We subtract 2 from each side. And in our calculator, we do log 20, close the parentheses, divided by log 4, close the parentheses, hit enter, subtract 2 from that number, and we get x is equal to 0.16. For 4, we have 3 to the power of 5x is equal to 27 to the power of 2x plus 1. So this 3 can stay 3 to the power of 5x. However, this 27 is going to turn into 3 to the third power times the power of 2x plus 1. So because our bases are the same, we can cancel them out and just work with those exponents. So we're going to have 5x is equal to, I'm going to distribute this 3. We have 6x plus 3. From here, I'm just going to get x by itself. So I'm going to move the 6 over to be with the 5x. I'm going to get negative x is equal to 3. Then I divide each side by that negative 1, and we get that x is equal to negative 3. For 5, we have 36 to the power of x plus 2 is equal to 6 to the power of 4x. So the 36 is going to become 6 to the second power times the power of x plus 2, and it's going to be equal to 6 to the 4x power. So from here, since our bases are the same, we're going to cancel them out. We're going to work with 2x plus 4 is equal to 4x. So I just distributed that 2 to work with the exponent there. So from here, I'm going to move this 2x over by subtracting it from both sides to get my x's on the same side. So I have 4 is equal to 2x. Then I'm going to divide by 2, and we get that x is equal to 2. For 6, we have 5 to the power of 5x minus 6 is equal to 50. So that 50 can't turn into 5 to a power of, so I'm going to take the log of both sides. So we're going to have log 5 of the power of 5x minus 6 is equal to log 50. From here, we're going to move the 5x minus 6 to be in front. So I have 5x minus 6 times log 5 is equal to log 50. We divide each side by the log 5. So we're going to have 5x minus 6 is equal to log 50 divided by log 5. From this, I'm going to add the 6. I'm going to do this, and then I'm going to divide each side by the 5. So in my calculator, I'm going to type in log 50, close the parentheses, divided by log 5, close the parentheses, hit enter. From that number, I'm going to just add 6 and then divide by 5, so I get 1.70. Or sorry, 1.69 is what I get, 1.69. For 7, we have 16 to the power of 3x is equal to 64 to the power of x plus 9. The 16 is 2 to the 4th power. We're going to multiply that by the 3x power. And the 64 is 2 to the 2 to the 6th power. Yes, 2 to the 6th power. So that's 2 to the 6th power times x plus 9. So my 2's are going to cancel. So I'm going to work with 4 times 3x, which is 12x, is equal to the 6 times x plus 9, which gives us 6x plus 54. I'm going to move that 6 over by subtracting it from each side. So I'm going to have 6x is equal to 54. Then I'm going to divide each side by the 6, and I get that x is 9. For 8, we have 81 to the power of x is equal to 243 to the power of x plus 2. So this 81 is 3 to the 4th power. This 243 is 3 to the 5th power. So we're going to multiply the 4 by x and the 5 by x plus 2. From here, the 3's cancel, so I'm going to work with 4x is equal to 5x plus 10. I'm going to subtract that 5x from each side. So we have negative x is equal to 10, and then we divide each side by that negative 1, and we get x is equal to negative 10. For 9, we have 1/2 to the power of 3x is equal to 8 to the 2nd power. This 1/2 is the same thing as 2 to the negative 1st power, so that's going to be multiplied by the power of 3x, and that 8 is 2 to the 3rd power times the power of 2. Those 2's can cancel, so we're working with negative 3x is equal to 6. We divide each side by the negative 3, and we get that x is equal to negative 2. For our next question, number 10, we have log 2 of x to the 7th power is equal to 21. So this 7 is going to move out front. We're going to have 7 times log 2 of x is equal to 21. We're going to divide each side by the 7. We get log 2 of x is equal to 3. The base on this log is 2, so we're going to have 2 as the base on each side. And then the log 2x and that 3 are going to turn into our exponents. So we're going to have 2 to the power of log 2 of x is equal to 2 to the third power. The 2 cancels out the log 2, so we just have the x left over, and 2 to the third power is 8. So x is equal to 8. For 11, we have log 5 of x to the third power is equal to 15. So again, we're going to take this 3, we're going to move it in front. So 3 times log 5 of x is equal to 15. We're going to divide each side by 3. We get log 5 of x is equal to 5. So from here, we're going to have 5 to the power of log 5 of x is equal to 5 to the fifth power. That 5 cancels out the log 5, so we just have x is equal to, and then that 5 to the fifth power is 3,125. For 12, we have log 6 of x minus 4 squared is equal to 2. So this 2 goes out front, so we're going to have 2 times log 6 of x minus 4 is equal to 2. We're going to divide each side by the 2. We get log 6 of x minus 4 is equal to 1. From here, our base is that 6, so we're going to have 6 to the power of log 6 of x minus 4 is equal to 6 to the first power. So from here, that 6 is going to cancel out that log 6, where we just have the x minus 4 is equal to 6 to the first power, which is 6. We're going to add that 4 to both sides, and we get that x is equal to 10. For 13, we have log x minus log 9 is equal to 3. So we want to remember when we're subtracting two logs and their bases are the same, we're going to divide those whole numbers. So we're going to keep the log. We're going to have x over 9 is equal to 3. Our invisible base here is 10, so we're going to have 10 be the base on both sides of our equal sign. That log x over 9 is an exponent, and so is the 3. So the 10 cancels out the log to where we're just working with the x over 9, and 10 to the third power is 1,000. So from here, we're going to multiply 9 on each side to get x by itself, so x is just 9,000. For 14, we have log x plus log 4 is equal to 1. So because the addition is there, we're going to multiply the x and the 4. So we're going to have log x times 4, which is 4x, is equal to 1. Our invisible base again is 10. So this is 10 to the power of log 4x is equal to 10 to the first power. The 10 cancels out the log, so that way we just have the 4x is equal to 10. We divide each side by 4. And x is equal to 5 over 2. For 15, you have log x plus 6 is equal to log 5x minus 2. So where the bases here are 10. So this is going to become 10 to the power of log x plus 6 is equal to 10 to the power of log 5x minus 2. Our bases cancel out the logs, so it's just going to be x plus 6 is equal to 5x minus 2. We're going to move the x over by subtracting it from each side, so we get 6 is equal to 4x minus 2. We add the 2 to both sides, and we get 8 is equal to 4x. So from here, we're going to divide each side by the 4, and we get that x is equal to 2. Our next part of our review works with those functions that involve e. So with all of these, what I'm going to do is I'm going to do e to the power of that negative 3 plus 3, e to the power of negative 2 plus 3, e to the power of negative 1 plus 3, e to the power of 0 plus 3, e to the first power plus 3, e to the second power plus 3, and e to the third power plus 3. So from here, I'm going to plug these into my calculator. So e to the negative 3 plus 3 is going to give me 3.05. e to the negative second plus 3 gives me 3.14. E to the negative 1 plus 3 is 3.37. The e to the power of 0 plus 3 is 4. E to the first power plus 3 is 5.72. E to the second power plus 3 is 10.39. And then e to the third power plus 3 is 23.09. So this is giving me ordered pairs of negative 3, 3.05, negative 2, 3.14, negative 1, 3.37, 0, 4, 1, 5.72, 2, 10.39, and 3, 23.09. So plotting these on our coordinate plane, first one we're going to have is that negative 3, 3.0 something, then 3.14 for the 2, and it goes up. Then we have 1, 5.72, so it's going to be about here. And then 2, 10.39. So our asymptote's going to be at that 3 on the y, so this line's not going to cross through that 3. For 11, I'm going to do the same thing. So I'm going to do the 3 minus e to the power of first. So I have 3 minus e to the power of negative 3, 3 minus e to the power of negative 2, 3 minus e to the power of negative 1, 3 minus e to the power of 0, 3 minus e to the first power, 3 minus e to the second power, and 3 minus e to the third power. So then we're just going to plug this into my calculator. So the 3 minus e to the negative third is 2.95. 3 minus e to the negative second is 2.86. 3 minus e to the negative first is 2.63. 3 minus 1 is 2. 3 minus e to the first is 0.28. 3 minus e to the second is negative 4.39. And 3 minus e to the third gives us negative 17.09. So my ordered pairs here are negative 3, 2.95, negative 2, 2.86, negative 1, 2.63, 0, 2, 1, 0.28, 2, negative 4.39, and 3, negative 17.09. So on my coordinate plane, I'm going to start with that negative 3, 2.95. Which is going to be about here. Then I have negative 2, 2.86. From there, I'm going to do 2.63 with negative 1 as my x. Then 0, 2. Then I'm going to have 1, 0.28. Then I'm going to have 2, negative 4.39. Oops. One more over. There we go. So my line is going to look very similar to this. And that's it for that one. For 12, we have f of x is equal to, f of x is equal to e to the power of x divided by 3. So once again, I'm going to just fill in my function table. So e to the negative third divided by 3, e to the negative second divided by 3, e to the negative first divided by 3, e to the 0 divided by 3, e to the first divided by 3, e to the second divided by 3, and e to the third divided by 3. All right, so I'm going to do the second e, or second ln, e to the negative third divided by 3 gives me 0.017. Then e to the negative second divided by 3 is 0.045, so that's 0.05. Then we have e to the negative first divided by 3, which is 0.12. 1 divided by 3 is 3 repeating, 0.3 repeating, so that's 0.33. E to the first divided by 3 is 0.91. E to the second divided by 3 gives us 2.46. And lastly, e to the third divided by 3 is 6.70. So my ordered pairs are going to be negative 3, 0.02, negative 2, 0.05, negative 1, 0.12, 0, 0.33, 1, 0.91, 2, 2.46, and 3, 6.70. So to graph these, I'm going to be really close to this x-axis. And then I'm going to go up from there, 2.46, about here, and then 6.7. So I'm going to get really close to this x-axis, but don't cross it. And then I'm going to go up from there. For 13, we have f of x is equal to 3 times e to the power of x minus 1. So this is going to be 3 times e to the negative third minus 1, 3 times e to the negative second minus 1, 3 times e to the negative first minus 1, 3 times e to the power of 0 minus 1, 3 times e to the first power minus 1, 3 times e to the second power minus 1, and 3 times e to the third power minus 1. So using my calculator, 3 times e to the negative third minus 1 gives us negative 2.85. 3 times e to the negative second minus 1 is negative 2.59. Then we have 3 times e to the negative first minus 1 is negative 1.90. The 3 times 0 would be 0. Then 3 times e to the first minus 1 is 5.15. 3 times e to the second minus 1 is 19.17. And lastly, 3 times e to the third minus 1 is 57.26. So this is going to give us negative 3, negative 2.85, negative 2, negative 2.59, negative 1, negative 1.90, 0, 1, 5.15, 2, 19.17, and 3, 57.26. All right, so that's negative 3, negative 2.85 is going to be about here. Then we have negative 2, negative 2.59, Oh, wow. Give me 1 second. So this is opposite of what I'm doing. So -3, negative, go down. Then we have 2, -2, -2.59. Still not right. Okay, let's try this one last time. -3, 1, 2, there we go. Then a 2.5, then the 1.9 down is here, 0, 0, 1, 5, 15, 2, 19.7 is not on this graph. So our line is going to look like this. For 14 through 17, we're working with ln and e, which are inverses of each other, so they cancel each other out. So for 14, we have ln times e to the second power. So the ln and the e cancel each other out, so the only thing you have left is the 2. And that is your answer. For 15, we have ln times e to the power of x over 2. So the ln and the e cancel. We're going to have x over 2 for our solution. For 16, e to the power of ln cancels each other out, so you're just left with the 1 minus the 3a. For 17, we have ln times e, which cancel each other out, and that b plus 5 is left over. For 7.5, all of these, we're treating them like we are when we work with a part. So we're going to look at all of these as if it says compounded continuously. Okay, so for 1, they give you an investment amount of 1,000 for a rate of 6% over 20 years. So we're going to use a part. So a is equal to p times e to the power of r times t, where your rate is in a decimal form of the percent. So this is 0.06. So we're going to plug all this in. A is equal to 1,000 times e to the power of 0.06 times 20. We're going to use our calculator. 1,000 times e to the power of 0.06 times 20 gives us $3,320.12. So we're rounding these all to the nearest hundredth because we're dealing with money. For 2, we have an investment amount of $750. We have a rate of 5.25%, so that's going to turn it into 0.0525 over 25 years. So we are going to use A is equal to P times E to the power of R times T. So A is equal to 750 times E to the power of 0.0525 times 25. So in our calculator, we do 750 second ln, so that gives us our e to the power of 0.0525 times 25. Hit enter. We get that A is equal to $2,786.59. For 3, we have an investment amount of $500. Our rate is 10%, so that's 0.1. And then we have 15 years. So A is equal to P times E to the power of R times T. So this is going to be A is equal to 500 times E to the power of 0.1 times 15. So for our answer, we are going to have 500 times E to the power of 0.1 times 15 gives us $2,240.84. For 3, we have $1,200 being invested, a percentage of 2.5%, so that's 0.025 over 10 years. So A is equal to P times E to the power of R times T. This is going to be A is equal to 1200 times e to the power of 0.025 times 10. So in our calculator, 1200 second ln, that gives us our e to the power of 0.025 times 10 is equal to $1,540.83. For 5, we have an investment amount of $1,800, a rate of 8%, so that's 0.08, and a time of 6 years. So A is equal to P times e to the power of R times T. That's going to be A is equal to 1,800 times e to the power of 0.08 times 6. So in our calculator, 1,800 times e to the power of 0.08 times 6 gives us $2,908.93. And for our last one, number 6, we have P is equal to 1,500. Our rate is 5.65%, so that's 0.0565, and we have a time of 3 years. So A is equal to P times e to the power of R times T. That's going to be A is equal to 1,500 times e to the power of 0.0565 times 3. So if we plug this into our calculator, we get 1777 and 7 cents. So $1,777.07.